All right, we know that from our English classes, conjunctions are words that connect, and a big one is and. When we talk about conjunctions in math, and is the only connecting word that we are going to use. When we talk about or, those will be what we call disjunctions. And then we'll have a second topic at the end of the lesson that's totally different. It's geometry, circles, chords and secants, and multiplying the lengths of those different segments that we get. Now, I know that you guys know what these two words mean. If I just ask about, if I give you a sentence with and or with or, you know what those mean. So stand if you are a male and you have dark hair, as in not blonde. Stand if you are a male or you have dark hair. Stand if you are a male or you are someone with dark hair. Okay, so with the first one, you two stood because both things were true for you, right? The rest of you who stood later stood because you were a guy or because you don't have light colored hair. But they did not, the last group, both things were not true, just one or the other. That's how we're going to use it, but we're going to be talking about math inequalities. And we're going to have our answers that make both descriptions true, or that make at least one of them, but not necessarily both of them true. So that's going to be a conjunction. Both conditions have to be met. So if you look at what I've got here, we have one inequality, then we have a second inequality, and we have the word and in between them, so it is a conjunction. Both conditions have to be met. So first thing we have to do is to simplify the inequalities so we have x all by itself, not minus x, not x plus 4, or whatever else might be going on. Griff, what would I do first to the one I underlined in red to simplify it? Which gives me everybody good with that? And Cooper, what do I do now? How do I do that? Okay, so we could do adding the x, subtracting the 3. Most of us, I think, say that we're multiplying or dividing by -1 to make that be an x and that be a -3. And if we do that, we have to flip it so that it goes the other way. So that means I'm going to be talking about integers that are greater than or equal to -3. So that's just kind of some scratch work there. It's got to make that true, and it's got to make the other one true also. It's got to be true for both things at the same time. So then let's simplify this other one. Allie, what do I do to this one? What does that give me? Everybody good with that? X is less than 2. So that's going to mean integers that would be going that way. Now I need to write an algebraic solution and a graph solution. Algebraic means it has the x in it. So I've got these two pieces, and I must repeat the word. I have to put and in between them and then circle them. Had to show that it is a conjunction. Now I need the integers for which that is true. So for the red one, I'd put a dot on the -3, -2, and keep going all the way to the right. For the blue one, I'd put dots on 1 and 0 and -1 and keep going to the left. I need to think about which ones am I talking about and make both of them true. Who can help me describe which points I need to put dots on? which dots make both of those true? Which dots are greater than or equal to -3? And at the same time, they are less than the 2. Yo-yo? And you stop there. So let me just catch up to what she said. Thumbs up, thumbs down. Do you agree with that? Looks good to me. Remember, we don't do open circles on the dot graphs, just on the ones where we're doing real numbers. These three numbers are bigger than or equal to -3 and at the same time less than 2. Questions on that? One last thing I'm going to show you about this one. I could turn this x is greater than or equal to -3 around and say -3 is less than or equal to x, right? Then, because that's less than, this is less than, they point the same way, I could say the x's have to be between -3 and 2, could be equal to -3, but not 2. And do you see how that matches the graph? You may only do the triples when it is an and statement. They do not work for ors, they mean and. Both arrows have to point the same way. In this case, they are both less than arrows. I can't have one going less than and one going greater than. And the outside numbers have to make sense with that direction. Is -3 less than 2? Yeah, so it makes sense. What would be nonsense, just so you get what I'm saying, it would be nonsense if I had one where I said 2 was less than x was less than or equal to -3, because 2 is not less than -3. So you got what I'm saying on that about it making sense. All right, this next one starts off as one of those triples. It is a conjunction. This means -1 is less than x minus 1, and x minus 1 is less than or equal to 3. We still want x by itself. If we have x minus 1 and we want just x, what do we need to do? Emily, if I have x minus 1 and I want just x, what do I have to do? And normally we're used to working on things where we have both sides, so we add 1 to both sides. This one doesn't have both sides, it has 3 parts. So we have to, at the same time, add 1 to all 3 parts. Then we do have x in the middle. -1 plus 1 is 0. 3 plus 1 is 4. So now we are looking at going from 0 to 4. The arrows make sense. 0 is less than 4. So the thing's between 0 and 4. This time all reals. So open circle on 0, filled in solid circle on the 4, shade between. Those are the x's that are in between. Algebraic solution written as a conjunction, and the graph solution. Give me a thumbs up, thumbs down, or in the middle. Feeling okay about that? Okay, we did an example at the beginning with just an English sentence about standing if this or that were true. And so you understood that meant, well, if just one was true, you'd stand. Could be both, but all you needed was one of them to be true. So now we're doing that with our number line. We have the word or in between. First thing we have to do is to clean up those inequalities. So Austin, what do I have to do to the first one to make it be just an x? And if you multiply by -1, what? It needs to change direction, so x is less than or equal to -3, or the next one. So is that much making sense to everybody? Are you agreeing with my work so far? Okay, now what about the second one? When we multiply that by -1, what will we have, Yesenia? So multiply both by the -1 and we have x and we have 1, turn the inequality the other way. So here's our number line. And now if it makes one true, we shade it. If it makes two, great, but all it has to do is make one shaded. So x less than or equal to -3 with reals. And we got that second arrow on there. Those all make the first one true. X greater than 1, those all make the second one true. So we shade both parts and keep both parts. Algebraic solution must have the word or in it and must have the x's simplified to where they're just x, not x minus 1 or minus x or anything like that. So questions with conjunction and disjunction graphs. Disjunctions will most often have two branches with a space in between them. There are a few special cases that do other things with their overlap. All right, circles now. This is review. We know about secant lines on the left. They cross inside the circle. I'm sorry, chords on the left that cross inside the circle. Secants are on the right and cross outside the circle. This picture is for finding angle measurements. So review that for me. How does that work? Ethan, how does it work if they cross inside? So what would that look like for this one? So let's see, 170 over 2, what's that? 85? So the angle was the arc plus the arc divided by 2. This is for finding angles. What about for the other one, Kip? So the angle is arc minus arc over 2. So 80 over 2 would be 40. What we're going to do today is not the angle measurements. It's how long are the pieces of the lines. So 3 formulas to write down. These have to do with the length of these segments. If they are chords, so they cross inside the circle, we are going to go along one of them and take one of the pieces times the other piece, x times y. So we get a straight line. We take where they cross and the left times the right, or the top times the bottom, depending on how you want to think of those angles cutting each other into two pieces, equals, and then we multiply along the other one. I don't want to see any fraction equal fraction stuff set up. We're going to multiply along one line segment and multiply along the other one until we have both complete straight pieces. Okay, the last two are ones that cross outside the circle. And what we're going to do is we are going to take the outside part, so A for that top one, and then not times the other piece, not like what we just did. Now it's going to be times the whole thing. So A plus B is the full length of the whole thing. And then I did the same thing for the other one, the outside times the whole thing. When we were doing angles, we had the same formula when the angles crossed outside, whether they were two secants like the top picture or a secant and a tangent. If they crossed outside, the angle was the arc minus the arc divided by 2. This is going to be the same formula that we just had. You do not have two different formulas. If they are both secants, it's outside times the whole thing equals outside times the whole thing. If they cross, or if one is a tangent line, it is still the outside times the whole thing equals the outside times the whole thing. So for the top one, we have the outside f times the whole thing, f plus g. The only piece that's a little bit different is for the bottom one, e is the outside, and e is also the whole thing. So that one becomes e times e when we do the outside times the full length of that particular segment. Any questions with that? All right, let's do 3 quick examples with these. So these cross inside. So we're going to take one of them and we're going to take one of its pieces, which is x, times the other one of its pieces, which is 5. We go straight across and we have 5 times x. Then we go along the other one piece times the other side of that same line. So we have the 3 times the 7. So 5x is 21. If I want just x, what do I need to do to both sides, Caleb? So we're going to divide both sides by 5 and write down that x is 21 over 5 or 4.2. Pretty easy, right? Just got to remember, multiply straight across. Okay, let's do 2 secants that cross outside. So the formula is outside times the whole thing equals outside times the whole thing. Griff, what do I write down for the top one? For outside times the whole thing. Everybody good with that for the top one? Is that making sense? See, Yo-Yo, what about for the other one? Very good. So outside times the whole thing. So 3, not times 5, but times the 3 plus the 5, or 3 times 8. And let's distribute. 16 plus 4x is 3 times 8 is 24. Everybody, what do I have when I subtract 16? 8, divide both sides by 4, and everybody, what do we get? So questions with that one. Okay, last example, outside times the whole thing equals outside times the whole thing once more. Write down what you think that equation should look like. And Ada, tell us what you've written down. Everybody good with 4 times 4 plus x for the top one and 8 times 8 for the bottom one? That means we have 16 plus 4x is 64. What do I get when I subtract 16? And if I divide that by 4, what do I have? So everybody feel okay with what we've covered today? All right, thank you.